name is Shai Bannon. I created Elasticsearch. And to be honest, I spent a lot of time trying to think about how to best present Elasticsearch in 15 minutes or 20 minutes. And I've been here a few times talking about Elasticsearch and doing my thing with like shell and a curl. And I thought maybe it makes sense to talk a bit about why Elasticsearch was created in the first place. What does it try to solve? So the first thing that I want to do is actually, this is one of the coolest venues that I've ever attended. So I'd love to take a picture, but come on. Okay. So it's tweeted, but it's going to be pretty bad because of the lighting. So what did I just do? I effectively just tweeted information, right? I just tweeted 140 characters, or a bit less. And is that big data? Or, I hate the term big in big data. What is big? But, well, obviously something that crashes Excel. What did I just do? I just tweeted 140 characters. Did it just end with tweeting 140 characters? Probably not. If you hook into the Twitter stream, the Firehose, or something like that, a single tweet actually is composed of all of that information up there. And you probably can say it then for a reason. There's tons of it per tweet. There's a lot of metadata that is associated with today's data. A tweet is a simple, unstructured text, right? 140 characters. But there's which location did I tweeted it from, the username, the followers, the hashtags. There's tons of metadata that comes together with a single tweet. Here's another example. This is actually an actual log message that comes out of a Unix system. I forget which one, to be honest. So I just picked it up. And then there's another question, right? I mean, is a log message just a bunch of characters that we try to search on, or something like an error log or something like that? Not necessarily. A log message has a lot of data associated with it, right? When did it happen? Which host name? Where in the code did it happen, so I can easily look it up instead of grabbing through it? Which IP address, process, so on and so on. And hopefully also who committed this line of code, so we can go ahead and try and figure out what should we do with him. Here's another example. In Elasticsearch, we like to eat our own dog food. So for example, whenever you download Elasticsearch, we actually take that download event, store it in Elasticsearch, and then use that to try and do some analytics around who downloads what. So this is an example of a URL of downloading Elasticsearch. Does that end only with this URL? Probably not. Obviously, it's important on when did you download Elasticsearch, where from. And by the way, France is dominated there, which I'm happy. Which IP, which geolocation, which product, which format. And just a personal note, whoever is downloading Elasticsearch 0.10 for some reason, it's a pretty old version. It's time to upgrade. Here's another example. So you probably know GitHub uses Elasticsearch to do a lot of things, search across a lot of different data that they have, but also around code. And is code really just code? Code is associated with the PHP, what language is it being written on? There's tons of information that is associated with the code, the history that is associated with it, who's committing what, to where, and so on. And actually, when you do a search like this one, you can actually figure out, for example, who doesn't do verify host when they're using curl, which must be important. Here's another example. You probably recognize this location. So, you go on and check in on Foursquare, which again uses Elasticsearch, for example. Is a check-in or a location just a latitude, longitude? You guessed, not really, right? I mean, it has a lot of additional information in it. The venue, the reviews, the name, the city, the country, maybe even the neighborhood that is associated with it. So what do we end up with? We end up with a lot of data that we need to be able to munge and effectively ask questions of our data. And this, I see it as a theme today in the talks. And actually, I love it when people use that term. You want to ask questions of your data. You have a lot of data, a lot of metadata associated with it, and you want to be able to easily explore it. So here's an example. During the elections in the US, Elasticsearch was used a lot to try and analyze what's going on and with the election and try to figure out, for example, who's talking about what and whom and what's happening there. So a simple question can be, show me all the tweets that mention Obama, right? This is an unstructured search. We're searching across those 140 characters for someone that mentions Obama. Then we have those tweets, but we'd love to start to navigate. We'd love to start to explore the data. For example, I don't know if you follow the US elections a bit, but Ohio was a swing state. So it's pretty important to understand who's tweeting about Obama in Ohio. So suddenly we have a bit more structure associated with it, right? This is a specific location, a state, for example, in the US. Here's another example. Who's tweeting about Obama in Ohio in the past month? Again, more structure that we want to have with our data. We start to explore the data. We feel that the data is effectively in our fingertips, and we just want to be able to explore it. The problem with that, for example, people in Ohio probably like to tweet a lot. So we end up with a lot of tweets there, even if we constrain it to the past month, right? And are we going to go 1 page at a time and trying to figure out what's going on when it comes to who tweets about Obama in Ohio in the past month? Well, let's take another step. Let's take all the tweets that mention Obama in Ohio in the past month, but break it down by day. And now what do we have? We can actually identify a trend, right? We can identify a trend about people tweeting more or less about Obama. But it doesn't end there. We'd love to change. We don't have to be constrained by how we define the data and be able to explore it in advance. We want to be able to change our mind and be able to ask questions of our data as they pop up. For example, we want to find all the tweets that mention Romney instead of Obama. Or we want to find all the tweets that mention Romney in California. Oh, and instead of in the past month, let's do it in the past year. And you know what? Break it down by month instead of a day. All of those questions, we need to be able to ask them and be able to answer them. So our data should allow us to ask those questions. Hopefully, also, with as little data munging as possible. We don't want to pre-compute, pre-design, predefine our data in a way that we will be able to ask our questions. So we want to be able to ask our questions on top of any attributes that is associated with our tweet, for example. We want to be able to aggregate based on any attribute that is associated with our tweet, and whether it's unstructured or structured. In Elasticsearch, for example, you can just take the Twitter fire hose and effectively direct it into Elasticsearch immediately and be able to answer all of those questions. So apologies, but I just came up with that name. I don't know if it's going to stick or not. But the idea here is that we're effectively looking for something interesting. The same way that we are using triangulation to triangulate our location, for example, using cell towers or Wi-Fi or something along those lines, we want to be able to triangulate the data that we want. We want to be able to triangulate what we're actually looking for. And what I've seen before I created Elasticsearch and while Elasticsearch was being used in the wild is that actually that triangulations involve text, regular text, metadata, a lot of structured metadata that is associated with that text, allowing us to slice and dice the data based on it, but also analytics, our ability to aggregate the data together. So effectively, when we're talking about it, it's the triangulation of unstructured data together with a lot of structured data potentially, right? I mean, it doesn't matter if it's 70 or 100 attributes that we have associated with our tweet, we should still be able to slice and dice the data based on any of those attributes. Just as a side note, go ahead and try and define 70 column indexes in a database and see where it can take you, right? That's a problem when it comes to regular storage systems. The next bit that is important to us when it comes to data is that we want it to be fresh. Sure, we can go and ask questions and get answers in hours, but hey, it would be nice if it would be milliseconds. So fresh means how quickly can we get results? If I now change my mind and I decide to slice and dice the data based on something that I didn't think in advance, if I want to do complex aggregations that are tied together, right, with the ability to slice and dice the data, how quickly can I get the results? Well, it would be nice if it would be milliseconds instead of hours. what people don't think about when it comes to freshness of data is also the aspect of how quickly can we see new data, right? If someone just tweeted a message and I can immediately search for it, that's extremely more powerful compared to being able to search for it when it comes to a day or 2 days later, right? It's probably going to be irrelevant in 2 days. So hopefully within milliseconds, we will be able to search on new tweets or new locations, new check-ins, new code coming in into GitHub, things along those lines. How big is the data that we can handle? Well, hopefully that's irrelevant. But just as a side note, don't try and run a system that stores 100 terabytes of data on a medium-sized box on Amazon. That won't work. So you do need to have enough hardware to be able to sustain what you're growing into, the operations that you try to do. But hopefully the system that you use doesn't constrain you in that regard. So you'll be able to scale out easily to hundreds of nodes and still be able to provide the services that you want to provide to the users. Another aspect, which is super important when it comes to freshness of the data, and what I've seen users actually ending up doing when they use a system like Elasticsearch, for example, is that they can immediately put all of that power to their users, right? So imagine building an analytics component. I don't know, show me all the tweets that we're mentioning per day or something along those lines. And as people type in the search box, that graph immediately changes to reflect whatever the person types in. So you as a developer that uses the system doesn't have to predefine to your users how they want to slice and dice the data. And this is a very powerful and enriching experience that applications can now provide to their users. So users feel on their own that they own the data itself, and you eventually actually delegate the exploration of the data to your users. That's an extremely powerful concept. So let's continue. So here's well, I've been doing distributed systems for quite some time, and there's effectively a very simple rule when it comes to distributed systems. I know there's a lot of CAP theorem and how to build distributed systems and how to have them communicate with one another and so on, but at the end of the day, collocation is what matters. The ability to collocate data and processing together is what's going to give you all of those things that we talked about before, the freshness of the data and the ability to ask questions and be answered in milliseconds. So obviously you know what the second rule of distributed systems is, but I'm going to keep the third rule for you to guess. And in order to achieve data triangulation, right, a system should provide all of them internally, built in. And this is super important, right? If you have a system that does, for example, full text search, and a system that does filtering based on metadata, and another system that does aggregations, what happens when I enter a simple search request and it matches 1 billion tweets? And I'm talking about actual use cases of Elasticsearch. Do I need to take all of those 1 billion tweets, stream them into the other system that does the metadata filtering, and then take all of those 1 billion tweets and then fire them up into an analytics engine to be able to aggregate them? That's not going to take milliseconds, right? That's going to take time. We have to move a lot of data around. On the other hand, if we can achieve collocation, if we can actually have a system that can answer all of those 3 questions together while collocated to the same box, obviously in a distributed manner, then we can answer those questions in milliseconds. So final words. You saw that one before, but that's a bonsai tree at the end. That's the main reason why Elasticsearch was created. The idea is to effectively live up to my personal dream, coming from a lot of search background and distributed systems background, which is effectively to put the power of data to the users, not focus, which I always found funny, like 4.5 years ago, and everything was happening, Hadoop, NoSQL, and what have you, and things like that. And when you looked at them, most of them were focused about how to store the data. But at the end of the day, I can store a petabyte-sized data. If I cannot actually explore it, what can I do with it? That's great. I have it somewhere. I won't be able to do anything with it. And that's what Elasticsearch focus is. I mean, we try to build a system that allows you to make sense of your data, to be able to ask questions like the ones that I told before. And it's easy to see online how you ask those questions, and I hope that it's as simple as we did it to be. But that's effectively the end goal of Elasticsearch. We want to make data exploration, the ability to go ahead and ask questions of your data and get results in milliseconds, available to end users. That's it.
Thank you very much.